Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these Algebra II section 6.7 notes. Alright, so here it says using the fundamental theorem of algebra. Alright, so my essential question today is how do I find the original polynomial if I am given the zeros. All right, so today we're going to kind of work backwards the other way. We've been taking the last few days or about a week or so to go through finding the zeros. Now I'm going to give you the zeros and you have to find the original polynomial. So just a couple questions for review on the top of this here. The fundamental theorem of algebra is really just this: an nth degree polynomial has n solutions. All right, so just a review for these guys says how many solutions and what are they. So this guy has an x to the first, so this has one solution. And that one solution, if I set it equal to 0, I get 0 equals 2x minus 1. I add the 1, I add the 1, I get 1 equals 2x. Divide by 2, I get x equals 1/2. All right, so that is the solution for that one. The next one here is looking at, it is looking at f of x equals x squared minus 2. So this guy has an x squared. It's got two solutions. So we need to try to find both solutions here, and you do that by setting it equal to 0 again. You get x squared minus 2. So if I add 2 to the other side, so I get 2 equals x squared. Take the square root of both sides, and then the square root of 2 is plus or minus the square root of 2 equals x. So that is where your two solutions come in. All right. So as I go on, the real new stuff today is looking at this. It says use the zeros you are given to write binomial factors x minus k. All right, then we're going to multiply these factors together to get the original polynomial. All right, so now as I look at this first example here, it gives me my zeros of 3, 1, and 7. So that means my k equals 3, my k equals 1, and my k equals 7. All right, so again, remember here when you put them into those polynomials, it's going to be x minus 3, x minus 1, and x minus 7. All right, so then number 2 here tells us, hey, I just got to multiply these guys together. So if I go through and multiply these guys together, remember we talked about if we have 3 of these things multiplied, we have to take these 2 first and then tack on this guy at the end. So let's FOIL these guys in. I'm going to go my x times my x is going to give me x squared. My x times my negative 1 is going to give me negative 1x. My negative 3 times my x gives me negative 3x. And my negative 3 times my 1 gives me positive 3. All right, here now I have x minus 7 still at the end tacked on. So I have x squared. These guys combine to make negative, 4x plus 3. And then I still have to tack it on with that x minus 7. All right, so now to finish this guy off, I actually have to multiply this x times everything, remember, and then the negative 7 times everything to go through there as well. So x times these guys is pretty nice. It's just going to be x cubed minus 4x squared plus 3x. And then the negative 7 times these is going to be negative 7 times x squared is negative 7x squared. Negative 7 times negative 4x is going to be positive 28x. And then negative 7 times 3 is going to give me a negative 21. All right, for my final answer here, I have to go through and combine some like terms. So my x squareds can combine, and then my x's can combine as well. So I have x cubed minus 11x squared plus 31x minus 21. All right, so that's my original polynomial that shoots out zeros of 3, 1, and 7. All right. Awesome. So now my last one here is a little bit trickier because it's got some i's in here. And the i's don't really mean anything different. It's just going through the i's. So now here are my k's again. I get 0, 2i, and negative 2i. All right, so these are some imaginary zeros here for these guys. So my x for 0 is going to be x minus 0, x minus 2i, x plus 2i for that last one. Okay. And the nice thing about x minus 0 is that's just x, and then I have x minus 2i, and then I have x plus 2i. So I can FOIL these guys together here. So I can go x times x times 2i, negative 2i times x, and negative 2i times 2i. So let's do that. I have x, and then I have x times x is going to be x squared. X times 2i is just going to be positive 2ix. Negative 2i times x is going to be negative 2ix. And the last one, negative 2i times 2i, is going to give me negative 4i squared. All right. Awesome. So now I can go through and look at what happens to my ix's. Those guys cancel out. They're the same. All right. As I flip this guy up here, I'm going to have x, and then I combine those. So I'm going to have x squared minus 4i squared. Okay, and if you remember here, what goes into I squared? I squared is always equal to negative 1. So if I plug in negative 1, this is going to be x squared plus 4, because this is going to be negative 1. So negative 4 times negative 1 is positive 4. And then my last step here, I can just distribute this guy in, so I get x cubed plus 4x. All right, so today really the new stuff here is looking at what are your zeros, what binomials do you have, these x minus k's, and then you just really just FOIL them together, multiply them together as you go. So if you have any questions, please come find me. I'm here to help.